Last day we have started with definition of function. We did. Now today we are going for representation of functions. So in detail we'll be getting the representation. Representation of functions. There were many ways of representing function. Right? The first thing is in the form of ordered pair. Ordered pair. In the form of ordered pair. In the form of ordered pair by set builder method. Set builder method. One is this and oblique tabulation method or tabular method or listing method, whatever you say. Both will be used, right? So if we represent a set like this, then how does it look like? So suppose f is a function from a to b. Last day we came to know that in that case f is a subset of a cross b, but be sure that it's a rule. It is a rule which relates every element. Just this is a recap we have already done. Every element of A to a unique element of B. This was the thing we got, right? So it's a function. Then f can be written like this in the help of set builder method in the form of ordered pair a comma b, such that b is equal to f of a. That is, this is the rule, and a is taken from set a and b is taken from set b, and we have to be assured here that this b is unique. That means one and only one b will get against every a. So this is one. And now if we write this function in the ordered pair form, say a1 comma b1, a2 comma b2, a3 comma b3, like that, suppose we have written whatever element we had, right? So in both the ways we can define the function, denote or represent the function, right? So here just few things you have to know. I'm just going to draw a figure for this so that we can understand this is in a better way. Suppose this is one set, because we have to get the idea of domain and range. Last day we have told about domain and range. So today again we are going to have it in a better way, right? So from here to here, this is the function. That means the relation which will relate elements of A to elements of B. So what I have written will tell you that A1 is related to B1, A2 is related to B2, etc. Right? This I am not going to complete. Just for example, I have shown it. Now, just try to remember. Just try to remember. Every element of the set A must be having some relative here. So this whole set A is called domain. Right hand side whole set B is called codomain, right? In B, we may be getting some elements which may be extra. So the element which are having the relations with elements of A, that set is known as the range of F. So be very, very clear. Domain symbol we can use for our, it's not a very standard symbol, but we can use, people will understand DF, D suffix F. For codomain we can write CDF. For range we can write R suffix F for representation of these particular three quantities, right? So in this particular case, like the relations, whatever we got in relations, this A is known as pre-image. pre-image of B1, and this B1 is known as image of A1. So now from here it is very clear that the first place elements in the ordered pairs will constitute the domain. So if we have the function in this form, we can write the domain readily just by listing all the first place element in the ordered pairs, right? And then arranges immediately the elements in the second place of the ordered pairs. Now there is a very important thing to notice. What is that important thing? Just let me try to tell you. To be a function, as we already know, that there should not be more than one image for elements in domain. So when we write the function in this ordered pairs, then we must be careful that there should not be any repetition in the first place element. A repetition in the first place element will tell you what? That element has two different images. Like outside I am writing for your reference. Suppose in the function I got these elements. I am saying that it is a function and I got this element. Then I'll be wrong. Because A1 has image B1, A1 has image B2. That means A1 is having two different images, which is contradicting the definition of function. So what we must see when ordered pairs are given, we have to only see that the first place element, there will be no repetition at all. So I am just writing, it is an important point, no repetition, no repetition in the first place element. No repetition in the first place element of the ordered pairs. Of the ordered pairs. This is very, very important to note. Now, number two, second way. This is just for understanding. So we do not have a standard method this, right? Just for understanding, we write function as a machine. This is just to understand function as a machine. Actually, to be very frank, every machine has a function, and this is nothing but maths only. Now, of course, higher level maths we use where background is function only. So what does this work do, or what should you understand by this? Let us just try to understand. Suppose this is a machine, right? And every machine has input and output, right? Suppose I have this input system and this is suppose output system of the machine, right? So here we will give input as X and some work will be done here. Work will be done, right? Work will be done. Work means I am not talking of the work of physics. I am talking something will be done by a rule. What is that rule? Fx. Fx is already told that it will do like this. So once we give the input, then here we'll be getting the output in the form of fx, that is y, right? So now machine will tell you what you should do when you give the input. Suppose the input what you give, machine should convert it like this. This is the work of the machine, right? Machine does this. So in that case, supposing that you give the input as 1. So when you wait for the output here, suppose this is a container where you will wait for the output. So what output you will get? You will get this as 2, because once you give 1, this conversion will be what? 1 square plus 1. That gives you 2. So that 2 will be in the container. Similarly, if I give the input as -1, what will I give? What will I get? Again, 2 as the output. Suppose somebody gives you 2 as the input, what will I get? It will be 5. Did you understand? So this is the way how a function works. Now, like the actual machine, what will happen? Every machine has restrictions, that Suppose, for example, I am trying to give you one small example. Say washing machine. You are talking about washing machine. You are talking about a washing machine, and you purchase it, suppose, and it is written 6.5 kg. What does that mean? That means the capacity of the machine is 6.5 kg. So maximum at 6.5 kg you can operate. And supposing that one day you have given the input as 10 kg, what will happen to the machine? Right? It will start malfunctioning, or maybe it will show an error. Why? Because the capacity of that machine is 6.5. So similarly, whatever function we have given here by defining a rule, it also has a standard mechanism. That means this will only work, right? So sometimes what will happen, every input may not work. So you have to be very sure what input should be given here and what input should not be given here, right? So in this particular one, when I'm saying x square plus 1, you can give all real numbers as input, all real numbers, right? All real numbers as input, as input. That means there is no restriction for you, because our main set is real number only. So here these inputs, right? These inputs, set of inputs means the domain. So here, as you can give all real number as input, your domain for this function will be real number. And whatever you are collecting here is the range of f, right? So suppose this particular function's activity has been changed. This machine's activity has been changed, and it is programmed that it is going to deliver you 1 by x when you give the input. Now you try to rethink. If your rule is to deliver 1 by x, what number should not be given as an input? Yes, exactly, you have found that should be 0. Because once you give 0 as input, right, machine will try to produce this. And this is not defined. That means machine will not work properly. That means you should be careful when your function definition is fx equal to 1 by x. Out of all the real number, you should kick away the real numbers 0. And in that case, this will be the domain. Right? So that is what the idea of function as a machine. So in this machine, roughly what we have understood, all inputs constitute the all inputs means all acceptable inputs. Remember it. All acceptable inputs are consisting the domain, and the outputs are giving you the range. Number 3, representation number 3, right? This is already we have done in case of your relation. So this is by arrow diagram, right? Arrow diagram. Arrow diagram, what we do, just quickly I do it because in relation we have already done extensively. Will not spend much time for this here. So directly I'll be telling you, these are the domain and codomain, right, of the set. And in this case, how do we define the elements? We write the name of the sets here, domain and codomain. Elements will be represented by the dots, right? And when we know there is a rule, then we just name the rule here. And once we are sure which element is related where, we join them by drawing arrow diagram. That's why we call it arrow diagram, right? That's why we call it arrow diagram, like this. So suppose this element is here. Now this is the element here. Now you see, here also we have something to observe. Here also we have something to observe. Very, very important to observe from the arrow diagram to conclude that it is a function or not. Simply looking at the arrow diagram, you can conclude whether it is a function or not. First observation what we should make is this. Number 1, no divergent arrowhead. No divergent arrowhead. or no divergent arrows. No divergent arrows means from one point you should not get more than one arrow. Because if from one point you get more arrows, it will indicate that this will have more than one image, which will not satisfy the uniqueness, right? So you have to just give a glance here. Is there any divergent arrow? If it is so, it is not a function. Number one. Number two, no free element. No free element in the first set. In the first set. First set means which we call domain. No free element. You can see here all the elements are engaged. So these are the two things. When you see an arrow diagram, you have to observe. If these are satisfied, you are done. You can say very clearly that this is a function, right? Of course, in the right hand side, there may be some free element, right? So in that case, what will happen? We will not include them in the range. So range will be a proper subset. Just you try to observe. This is also an observation. Range will be a proper subset of codomain. Proper subset, right? Proper means, what does the word proper means? Codomain will have some free elements. That is very, very important to note, right? So please go through it. Now we have two more representation. This representation I will not discuss because already I have discussed in explanation of relation. So I will not waste time here for doing these representations. Now gradually I'll be going for the main part, the working part of the functions, right? Actually, whatever we have done with domain range definition we have given, that definition may not work always. Working definitions will be little different. So first I am going to write that. That is very, very important to know, right? So we'll write this as a note. Let y equal to fx be a function from a to b, right? Okay, then the set of values of x for which f is defined. Please see the word I have used, f is defined. Defined का मतलब क्या है? Defined का मतलब है that is fx will have a finite value. एक finite value होने का मतलब है it is defined, right? अच्छा, फाइनाइट वैल्यू किन सेंस में, ये भी देखना पड़ेगा कि ये फाइनाइट वैल्यू बी में है या नहीं. अगर बी में नहीं होगा तो यू कैन नॉट एक्सेप्ट. इनफैक्ट इट इज द acceptable value of x, right? You can write set of all acceptable values of x for which fx is defined. तो इसको बोलते हैं, is called the domain. This you have to understand. Right? ये बहुत जरूरी बात है. This is about the definition of domain. Now next, right? The set of values of y such that y is equal to fx where x belongs to the domain. That means whenever you are giving the acceptable input, you will be getting some output. That output is called the range of the function. So these are two working processes by which we proceed for finding the domain and range. In course of time, we will be getting different ways. In course of time, we'll be getting different observations. That depends on the various problems. So it's not that these two only will serve or suffice your complete process, right? It will not. Next, many times when we try to find a domain, we make correct inspection. Correct inspection matlab observation, right? Our observation must be very, very strict. So this is the very important point you have to keep in mind when you find the domain and range of function, inspection or observation, right? This is the part which we should always keep in our mind. Secondly, two things, right? Only two things I am going to talk about. In case in whole function process, we'll be getting various type of functions with various restrictions, but basically we may encounter a function of the form p by q, where these are functions, these are again functions, or these are expressions involving x. So if I'm talking about the value which will satisfy this, very obviously you should tell that q should not be equal to 0, because if q becomes 0, this will lose its existence. Secondly, if you find something which is inside the root over, then this will be well defined for us if we get this quantity under the root as 0 or maybe a positive number. For negative numbers, square root you cannot find. Actually, these are only to the basic ideas which will stick to in order to find the domain and the range, right? So go through it. Okay, so now next, two different types of basic function. Out of that, one will study, right? So that you try to understand first. That is very important to know, because many students actually they do not know the difference afterwards. We have basically two types of function here. One is a real function, right? And number two type will be real valued function. Real valued function. So in our syllabus, basically, or maybe for the complete study at higher secondary level to this, we study only real functions. We do not study complex functions or real valued functions, right? So first, let me try to tell you what is the basic differences. For a function f from a to b, if domain is a subset of real number, codomain is also a subset of real number, then f is called real function. So more, all the functions what we will study are real functions here. And if you are saying for a function f from a to b, b is a subset of real number, you do not know about a, then f is called a real valued function. That means output is real. Input what it is, we do not know. Right? Now, here I do not have to give examples, because a lot of examples you are going to get immediately when we start with. Here I'll be giving one example. First one example, which is just to make you understand. It will not be a mathematical example, just to make you sure that what real valued and what real function is, to make a difference. I'm giving you. So do not try to cite this as an example when somebody asks you for a real valued function. Suppose a and b, f is a function. F tells you what? If I write something input here, it tells you number of family members. Suppose ये मेरा function है, ये करता है. That means here we'll be getting families. If f1, f2, f3 are families, and I want to relate them with some numbers that will tell you the family members, right? Suppose like this. So now you can see every family will have some members, so it is definitely a function. But these families are not subset of real numbers. So, but the see outputs are real numbers. So it is a real valued function, right? To make you understand. But if you ask me, sir, you give me one example which is actually a real valued mathematical example. So that also I give you, but I'm little reluctant because we do not study till now the complex number, but still I give it to you now. When as and when we'll do complex numbers, we'll understand that this example is a real valued function, right? Suppose I give you the function here, it is a set of all complex numbers, and here it is a set of real numbers, and I say you that here if I get a number like this, a plus ib, I want to relate it to a square plus b square. Now you can easily see, right? A plus IB. This I is a special quantity. I think you have already started little about this because you are preparing for Olympiad. So I is minus of root over minus of 1. That is the imaginary quantity. So when I consider any number like this, I want to relate it with a square plus b square. This A and B are real numbers. So overall, this number will be a real number. For example, if I write 2 plus 3i here, my right side relation will be 4 plus 9, that is 13, right? Similarly, if I write simply I, this will be related to 9, like that. So you can see all outputs are real numbers, whereas inputs are not real numbers. So this is a good example of real valued function. So now we are going to have algebra of functions. Algebra of functions means some rules we have to know, right? Some rules we have to know, which we call algebra of functions. Algebra of functions, or rather you can say property of functions, because these properties are needed. Let f is a function from a to b and z is a function from c to d. Then how do we define the addition? F plus g, suppose I want to define. So this will be defined as f plus z of x, that is fx plus gx, where this x, remember it, this is a very important part, this x should not be only taken from a, because a is containing all those values which are being satisfied by the rule f, whereas c contains which are being satisfied by g, but here you mix both. So you have to precisely take those values which are both common in a and c. So you have to be very precise here. Many persons do not write this. Even if you do the difference, same idea will be there. As and when both the part of the functions are used, you have to pick the values from the common domain, right? If you do the multiplication of the function, then the rule is fx into gx, the values, and then x will be again taken from here. And then if you even do the division, right, then also this will be fx by gx. Acha. Now from where you will take the values? A intersection C, to you will take definitely, but you should be also taking the values which will not make gx 0. So how do we write? We write all x, right? All x such that gx should not be 0. This must be very, very careful. That must be clear. Here, if any by chance values are there for which gx is 0, that should be excluded, right? So this is one of the part, and one which I have written for root over fx, right? Suppose root over fx, I want to find fx to define, right? What I should take? F of x should be greater than or equal to 0. These values I should take, right? That means those x for which fx is greater than 0. These are the things we have to take care when we work on functions. So the inequality which are going to involve in finding domain and range, little bit of glimpses I give you, so that afterwards it will not create problem for us in understanding this. So I'm just writing important. I am not writing in detail, just I'm writing it as important. So suppose A is greater than B, right? Then what will we get? In both the sides, if you add the same quantity, right? Or if you subtract the same quantity, right? Then inequality will remain same. Maybe this is, so this is true for all these, right? I have written the inequality only for greater than, but it is equally true for all this, right? So these inequalities I am not writing in the side, I am writing, right? Then in this case only, I can write this also. AC is greater than BC, right? Provided, remember, this multiplier is positive. But if you multiply with negative numbers, then inequality will get reversed, right? These are the things which we need, right? For example, I want to show you, suppose 2 is less than 3, and you want to multiply both the side by -1, then you will be getting -2 and -3. Now what will happen? You see, inequality will get reversed because you multiplied by minus negative numbers. Had it been positive numbers, inequality will have been retained. Similarly, if you do the same thing, divisions, right? So what will happen? If you do the division by positive numbers, inequality will be retained. And if you do the division by negative numbers, it will be reversed. That is to be understood very, very clearly, right? Similarly, if you want to add two different inequalities, be very, very clear that they should be in the same footage. Like if it is less than, this should be also less than, then you can add and subtract, right? Both will be valid and inequality will remain same, right? And of course, you can multiply also. You can multiply also, but there are some conditions. This doesn't hold every day. It will be true if all these numbers, what you are going to consider, are positive. If they are positive, then only this will be true. But otherwise, they will not be true. So these are the things we have to remember basically. Then some more are there that also I am going to discuss. I am very sorry. Here there is a mistake. It should be A plus C. It is B. In both the cases, B. It should be B in both the cases. Sorry. Now something which is very, very important. Now something very, very important. Number 3, I'll give. I'm continuing with the same number. Suppose you got multiplication like this. Actually, midterm factorization will generate this. And I want to talk about the character of this. Matlab, whether it is positive, whether it is negative, right? This one thing I would like to say, that A is less than B. A may be positive, A may be negative. There is no restrictions, but A should be less than B. This is the convention I want to take. In that case, where will this quantity be negative? Where will this quantity be positive? That must be known to you, right? So readily how you will find. We'll go for its proof extensively. That is not an issue. But presently, for taking the domain and range, we will see the process how to do it, right? So as A and B are negative, you just look at these two factors and find their zeros. They are nothing but A and B, right? So immediately you put the values in the number line, right? In the values in the number line. Then this particular part, that means the part which is between A and B, this gives you negative values. So I am writing in the symbol negative values. In this way, if you write, you will never forget. And the outsides will give you positive value of that particular expression. Positive value. right? So now if I write the conclusion, I can say it like this: x minus a into x minus b will be negative if x will be in the open interval ab, and x minus a into x minus b will be positive if x will be belonging to where? This side, you see, minus infinity to a, minus infinity to a, or means union will come b to infinity. So these two are the very important observation which you have to make. I did only for less than inequality, right, or greater than inequality. I did not take greater than or equal and less than or equal. That is not an issue. When it will be involved here, only close interval will come, right? Only close interval will come, right? Only close interval will come when you talk about equality of zero. So I just want to take one small, a quick example here, right? Suppose somebody asks you that you tell me where will this expression becomes negative, right? If they will say simply solve for real number that this is less than zero. So now you can process, go for a long process, but instead of that, you can say it is negative. Oh, it is between what? Open interval 2 to 3, right? Am I clear? Had it been equal, suppose this is number one, very quickly, I have told you, suppose I am giving you this x minus 2 less than or equal to 0, I have given this time. Then where will this lie? Less than or equal means these points are to be considered because they will make it 0. They will make it 0, right? They will make it 0. So here, what is the smaller one? Minus 1, and bigger one will be 2. See, I am talking about the zeros. That zeros has to be zeros are to be considered. One is minus 1 and 2, and this is the smaller one. So smaller one should be always in the left side. So this value will be giving you what? Close interval I need, because 0 has been asked. So your values are between this. And suppose I ask you this for say x minus 3 and greater than or equal to 0. Then where will it lie? It lies in the outside, right? So it will lie where? See, at the same time, equality is there means close interval, but infinity will not be considered in the close interval. So here in minus infinity to minus 1, union here 3 to infinity, right? Please see this. So in this page only, just let me tell little more about this, because this we can generalize now. Instead of talking about the product, we can talk about the divisions also, right? We can talk about the divisions also. Same rule prevails, right? Same rule will prevail here also. If suppose I need this to be greater than 0, then my x will belong to which place? This. And if it is, sorry, I'm sorry. So no, this is not greater than 0. This should be less than 0. Very sorry. Less than 0. And if it is greater than 0, then x should belong to minus infinity to a union b to infinity, where my that supposition is still true that a is less than b, right? So now I want to take one small example for this also, because that also is to be uh, calculated, right? Suppose x1 by x plus 3, I need less than or equal to 0. What do you say? Less than, so there are two values. One is 1, another is minus 3, right? Minus 3 is smaller, so less than means it will belong to minus 3 to 1. Uh, Equality. You see the previous case, when I talked about equality, I told you you should put close interval. But remember, not blindly. Here I cannot take x equal to 3, minus 3. Because if I take x equal to 3, result will not be existing. Forget about being negative. It will not exist only. So even if I have equal sign, here I should exclude 3. So this is to be very clear. Because of that I picked it up. Because of that I picked it up. Right. Okay, next one more thing I'll consider, and then we can be in a position to start the questions. Number four, suppose I consider. Now this time, if somebody tells you this particular ones, x square less than or equal to a square. Acha. Actually, what happens? This has the same background what you told, what I have told you. I can do it. I show you the background. I can bring it here, and you can now see this can be factorized, and it is actually related to the previous one only. So directly I am writing, if it is less than or equal to this, I can write what? I can directly write x will belong to minus a2 plus a close interval. And if it will be strict inequality, then x will belong to minus a to a open interval, right? Of course, one thing is very sure, a should be a positive number, of course, right? So similarly, if you talk about the other value that is greater than or equal, then this will give you what? X belongs to minus infinity to minus a union a to infinity. And if it is strictly greater than, then this will be giving you uh, minus infinity to minus a open interval, and this is a to s. Right, so this is a very very important part, very important part, right? Please make sure that you understand it. If you have any questions, queries, you can ask me. I'll take two like explanation for this so that we'll be comfortable with this. Anything to ask?
No, sir.
Okay. So now you see where you will be getting. Acha, one more thing. These are equivalent. Please try to know that if I write like this is equivalent to this. Because A is positive, I did not put modulus. And if it is like this is equivalent to this, right? Because many a times students commit mistake. What mistake? I'll be telling you, right? I'll be telling you. Because of that only, I picked up the example immediately. First, I'll do the correct one. Suppose somewhere you got a relation like this tomorrow. So, and you need to now conclude what type of x will be there. So, you should tell immediately, right? My x will be in minus 3 to 3, right? If you get suppose x square greater than 16, so you should be able to tell immediately that x will belong to minus infinity to minus 4 union 4 to infinity. But what foolishness usually some students do, when they get suppose x less than or equal to 16, suppose they get like this, they directly take the square root and they directly wrote it as this, which is absolutely a wrong thing, right? It is incorrect. So be very clear. In inequality, we do not have this defined or correct. So please make sure that you understand this particular part very clearly. Very clearly, right? Now I will to the next board, and now I'm going to explain you a very important part that is called the sine rule, right? So this will tell you how to decide the sign of an algebraic expressions. It's in the general form, right? Very important. Many person tell many names. I call it sine rule, right? SIGN, sine rule. So in which particular cases it is applied, that you try to understand. It is applied to those expressions. Of course, remember we can modify this also for many functions, but I'm talking first about the basic one. where you have got linear factors. Suppose any expression has been expressed somehow by in this format, right? In this format, suppose you are able to express this linear factors. Of course, they may be repeated. Say it is repeated for n number of time, n1, n2, n3, right? These are the power. Now, just for your information, like now, let me tell you, these powers will be natural number, right? At the beginning, I'm talking about they are natural number, or you can call them integers also. Negative numbers can be also there. Negative numbers, if it will be power, then they will come in the denominator. So now, if I want to ask you that, can you tell me where these numbers will be positive, where these number will be negative? Right? So what is the process that is assigned? I'm going to explain you very, very clearly in a general expression now, and then immediately I'll take one small example so that you will be very, very clear about this, right? So for that, the first thing you need to do about plotting these zeros of each of the factors. Now here, I just take a convention that these are already in orders. Suppose these are already in orders, right? Just to explain you in general. So I have to put them in the number line. I have to put them in the number line. It is not necessary that you should maintain equal gaps, exactly same positions where usually you put the numbers in graph. No, just you keep the logical places same. Like positive numbers should be in the right side. Like this, you have to keep these things in your mind. After that, listen very, very carefully. After that, here too we will not be able to identify much, but whenever we do examples, we'll see. You always see whether the factors are in the form of x minus a. If it is a minus x, please make a change and bring that in the form of x minus a. This is the very first and foremost information you need to remember. Here we are not talking about the values. Here we are talking about the sign of the values of x. Right? So now starting point. After explaining or expressing in this way, overall expression, what sign it bears here you see. If I write nothing means it is positive. If I write minus, then means it is negative. So consider this as positive. In that case, whatever is the extreme right point, you draw an upper curve. Meaning is that towards the right of a 5 point, all values if you put here, you will be always getting positive result, positive value of fx. After that, next, listen to me very carefully. You are now going to fill up the left of the parts. Always you should start from the right, then you should go to the left. So now how will you do? You observe the point. You are now moving from A5 to A4. So in that case, you see what is the nature of the power of A5. It is even or odd, because as it is integer, it will have only two options, even or odd, right? For a moment, I want to take N5 as odd to illustrate. If N5 is odd, moment you pass through A5 and you go to A4, during this course of time, you will sense the side. You will sense the side means earlier you were in the upper part of the line. Now you will be coming down, indicating that the values between A4 and A5 will be minus. Now repeat the same process for each point. Now you are about to pass through A4. Now look at what is the polarity, not polarity, what is the nature of N4. It is even or odd simply. Suppose this time I want to consider N4 as even. Even if it gets, then you will retain your position. Means where you were just previously, the side you beard, that side only you have to continue. Then now you see A3. If suppose A3 is having odd, this is suppose odd, then you will change the sign now. Earlier below, now you will come up. So up to the next point, remember it, up to the next point. And you just continue like this. And once you finish with this, now if I ask you where will this fx be positive, so you now can write easily that my interval will be minus infinity to a1 and then union a2 to a3 and then union a5 to infinity, and reverse it is negative, right? Now I'm going to take some examples in order to illustrate this, right? Some examples. Let us take some easy examples so that we can easily identify this, right? Let us take one known example so that we can better explain it, because I have explained you this just before a few minutes. Suppose I need this, where it will be negative. So in the first inequalities already before that, I explained you that negative should be in between 1 and 3, right? Open interval. Acha. Now let us use these particular observations here, right? Will it give the same result or not? Let us just see. Actually, this is what I explained is general. So here 1 and 3. Very nice. Now you see, you do not go for this because this is my target. You consider this as a fx, and now I'm asking you whether it is negative. So first you identify whether it is positive and negative. Last में conclusion देंगे. So now you try to see. You are about to pass to the point 3, right side, rightmost point you have to take. What is the sign here? The sign is positive. Means to the right it will be positive. Then you are about to pass to 3. What is the power of x minus 3? It is 1. That means odd. That means odd. Odd means you will not keep your side retained. You have to cross the side. So you come to the next side up to the next point. Right now you are about to pass to the point 1. So you see what is the power of this 1. That means odd means again you have to change the side. And now this will be telling you very clearly that your x, in order to be negative, it should be from 1 to 3 open interval. That's all. That's all. Or in case we use equality sign, then these points are to be included. But that time you should be alert whether those points inclusion will make your function defined or not. If the denominator will contain that part, then the function will not be defined. So in that case, you have to exclude that. That also I'll take now. So this is one example. Now I want to take one example with bigger factors. Bigger factors. First, let me take only linear factors with factors with power 1 only, right? Then we'll try to justify for bigger powers. Suppose I want to find the sign of this expression, right? Suppose where it is plus and where it is minus. So now idea is same. You have to draw the number line. You draw the number line very quickly and you identify and plot the points, whatever are the zeros. So zeros are, one is -1, one is 2, another is 5. Okay, very nice. They are already in order. So -1 will be here, 2 will be here, 5 will be here. Now from here only you can see I should not include 5. So if you want, you can put dark dots here and you can write open, because 5 will not be considered at any cost. Because if you put f of 5, this function will have no value at all. Undefined value will be getting. So now as usual, it will go plus. Then you are about to pass to the point 5, that is generated by this part which is having power 1, that is odd. So you will change the sign up to the next, right? And then actually what happens, let me try to tell you. If the factors are having only power 1, automatically alternatively plus minus will come. So here actually we need not justify much, just start with positive, then just go on changing the sign between the points. That's the idea. So here now if somebody asks you Bhai, you tell me where it is greater than or equal to 0. So x will be lying between where? -1 to -1 to +2 close interval union. 5 you cannot take, remember. Open interval after this. That's all. So you got this. You got very quickly, right? You got it very, very quickly. Now, one more question here only I want to take with some bigger powers. You can test it. Suppose you got this as x plus 1 whole square and then x minus 1 whole cube. Eh, this is square, please adjust. And suppose this is x plus 2 to the power 5. Okay, so now first of all your job is to now identify the zeros at the beginning सबसे पहले काम वही है. So zeros are 1 0 is -1, 1 is 1, another is -2. So -2 will come here, -1 will be here, and 1 will be here, right? Overall sign क्या है इधर? Plus. मतलब your right side will be starting from here. Right side will be starting from here. Great. Now you are about to pass to the point 1. 1 is being generated by this. Power is odd. If it is odd, up to the next point, you have to change the sign. Side you have to change. Changed. Now -1. -1 is having power 2, which is even. So till the next point, you will retain your side. Then you are about to pass to the point -2. It is odd. That means you have to now change the sign. So now it is very, very clear. It is very, very clear. Now, if somebody asks you that, please tell me where my values will be less than or equal to 0. So it will be what? You be very, very clear. This will not be included because it is in the denominator. So it is -2 to -1. It is, acha, I can write continuously because there is no gap, right? Instead of writing union, you see from here to here continuously it is negative, right? So if you find this, do not write separately. Right? Even if you write separately, it will not be wrong, but do not write it because you have a scope now from this. It will be negative. Right? Now see one more example I want to take. Example. Supposing that I want to know this 6. I am giving you one expression. And now I am saying, you tell in what value this fx is going to be negative, right? So how do I do? You do the midterm factorization. You do the midterm factorization. Midterm factorization करने के बाद your idea remains the same. What you will do? You will put the values. One will be -3, another will be -2. Great. Now linear factors with power 1. So this side plus, then of course, already I told you, if linear factors are having power 1 only, it will be just go on changing it. So now you tell where fx will be less than or equal to 0. It will be less than or equal to 0 if it is from -3 to -2. Great. Okay. So इस टाइप का प्रॉब्लम तुमको मिलेगा. You'll be getting this kind of problems. Right? अच्छा, अगर बाई चांस ये तो एक हो गया, you get a quadratic expression which is not possible to factorize in the this integral factors. अगर तुम मिड टर्म फैक्टराइजेशन को यूज करके इनको फैक्टराइजेशन नहीं कर पाया तो क्या होगा? So let me try to go for that kind of question also. Right, so let me just try to give you this. Say it is 7, right? So if I give it 7, sorry, it will be having imaginary root. Let me avoid that. Okay, now you see, already you know about the discriminant, so that I use actually orally I calculated. You see discriminant will be -1 square minus 4 into 2 into minus 7, that is giving you 1 plus 28, 56, right? So 57 is the value. So here, how you will do now? Problem is there? No problem at all. You use the quadratic equation and you solve the value, solve the equation, right? So it will be like this. Now out of this, they are real numbers. There is no problem at all. They are real numbers. So now just you tell which particular point you will put the values. पहले तुम आइडिया करो कि कौन सा छोटा होगा. छोटा वही होगा जिसमें माइनस होगा. तो it will be plus 1 minus 57 by 4 here, and this will be in the right side, right? अब वही बात है, लीनियर फैक्टर्स होगा, यहाँ पे दो ही फैक्टर्स होगा, जो भी होगा लीनियर फैक्टर्स ही होगा. सो इट विल बी लाइक दिस इज माइनस, सॉरी प्लस, दिस इज माइनस, दिस इज प्लस. अब अगर तुमको इसका पॉजिटिव वैल्यू चाहिए तो पॉजिटिव कहाँ है वो निकालो, नेगेटिव चाहिए, नेगेटिव कहाँ है वो निकालो. सो आई थिंक आई एम क्लियर हियर. I think I'm clear here. One last example I want to discuss. One last example I want to discuss. X square plus x plus 1. I have taken one equation, or I can say quadratic polynomial. Now I want to ask you where it is positive or where it is negative. Now here you may encounter this kind of quadratic equation also. Here you try to see what is the discriminant. Discriminant will be that is minus 3. So it has no real root, right? It has no real root. Very nice. That's the important thing you have to know. रियल रूट नहीं होने से तुम नंबर लाइन में इसे बना ही नहीं पाओगे, पहला ऑब्जर्वेशन. तो इसलिए इस पूरे एक्सप्रेशन का साइन या तो पॉजिटिव होगा या तो नेगेटिव होगा, कुछ एक होगा. दोनों में से, दोनों मिक्स होकर नहीं होगा. Either it will be completely positive for every value of x, or it will be completely negative for every value of x. कैसे डिटरमाइन करोगे? ऑफ कोर्स आई एम गोइंग टू एक्सप्लेन यू दिस वेरी कंप्लीटली, बट आज प्रिलिमिनरी के लिए बोल रहा हूं. वंस यू गेट दिस एज नेगेटिव, देन जस्ट सी द साइन ऑफ दिस. साइन ऑफ दिस मतलब कोएफिशिएंट ऑफ x स्क्वायर. इफ इट इज पॉजिटिव, if it is positive, fx will be always positive, and if it is negative, fx will be always negative. This is the thing you can observe. You can easily see the equation what we got here, the function what we got here. You give any input, it will be always positive every time, right? So this is what I wanted to explain you today, and I'll finish this today. Then we'll take more problems on relation and functions. First preliminary problem, then type functions we'll discuss. It will take a lot of time, but I'm sure that I'll explain you this to you.